Hey guys, welcome to Simply How. I got a request from a friend asking how turbine engines work, so I'm just going to run through quickly. I'm not going to get into too much detail, but try to keep it fairly simple. You basically have your intake, compression, expansion, exhaust. So for a turbine engine, it's a little bit different than a regular car engine or piston reciprocating engine. You have your intake. Then you have a series of compressor blades. This is a shaft. This is spinning. This is what it looks like from the front of the engine. There would be a shaft in the middle, and you'd have all these blades coming around. There would be little airfoils like this. Now these little airfoils basically are a tiny little wing, and it forces the air farther into the compressor. The compressed air enters the combustion chamber. This combustion chamber is where it's introduced, the airflow is introduced to fuel. So let's draw a couple fuel nozzles here. These would be all the way around the engine. So this is what it looks like from sort of a front or rear perspective. So you'd have your combustion chamber, kind of looks like this. You'd have all your fuel nozzles around the engine like this. Now, in front of that are your compressor blades. So you'd have your shaft, and then you'd have all your compressor blades. Compress, gets sent into the combustion chamber. Fuel is spraying in, lights the compressed fuel air mixture, and this is where it creates expanding gas. This is hot. You got flames in here. Now you have all this expanding gas. Where does it go? It goes out the back, right? So we're not just going to let all this escape. We're going to put some turbines here, some more turbines, kind of like the compressor ones, but now they're working in kind of like reverse. So you have more blades. Now engineers can figure out what the most efficient way is to capture all of this expanding gas, right? So everybody has a different way of doing it. Now we can attach this shaft to a turbine in the back. That's what powers the actual compressor. The rest of the gas that is coming out the combustion chamber can go through these other series of turbines, which then power whatever you want. So this is like a super basic, harsh explanation of how a turbine engine works. Your intake, air is compressed, the air is mixed with fuel, expansion happens, the expansion goes out the back through whichever turbines you put there, which we could call the power turbines, because that's what's creating the power. You got your turbofan engines found in airliners, passenger jets. Turbojet engines, these are more found commonly in fighter jets. Turboshaft engines, found in aircraft as well as helicopters. They're fairly common, I believe. And then you have your free turbines. These are also commonly found in aircraft, smaller aircraft. Turbofan engines. This fan is what you see on pictures of airliners. So when the air enters, gets sent around, or it gets sent through, the air that gets sent through the engine is sent through the compressors. The compressor then sends the air to the combustion chamber where it's introduced to fuel. Lit expands, and the expanding gas gets sent through the compressor turbine. Compressor turbine powers the compressor itself. The rest of the expanding gas gets sent through the power turbine. The power turbine powers the fan at the front of the engine, which in turn sends air either through the engine or around the engine. What's left is exhaust. The exhaust is sent out the back and mixed with the airflow from the fan. So you have this combination of exhaust and fan airflow to produce thrust. Turbojet engine. All of the air that enters the engine is sent through the compressor. It's then sent into the combustion chamber where it's mixed with jet fuel and ignited. This expanding gas is sent through the power turbines, which power this compressor, and what's left is sent out the back as exhaust, creating thrust. Turbo shaft engines. All of the air that enters the inlet is sent through the compressor. This compressor compresses the air and then introduces it into the combustion chamber where it's mixed with fuel. The expanding gas inside of the combustion chamber is sent through the power turbines. Now, these power turbines are directly connected to the compressor, as well as connected to the drivetrain that is connected to whatever source you want to power. So in this case, I have it drawn as a propeller, but you could also have it set up to a transmission or a gearbox that may power helicopter blades or whatever it may be hooked up to. This also creates a little bit of thrust out the back from exhaust. Free turbine engines. All of the air, again, that enters the inlet is sent through the compressor. Once it's compressed, it gets introduced to fuel in the combustion chamber where it's ignited and expands. The expanding gas is sent through the power turbine, the compressor turbine. The compressor turbine, its job is to run the compressor itself. So expanding gas gets sent through this turbine, which in turn creates it to spin, which spins the compressor. Once this air or expanding gas goes through this turbine, it then enters your power turbines. There's still a lot of energy here. This energy powers the power turbines, which then is connected to a second shaft. That's why it's called a free turbine, because this compressor shaft and the power, I guess you call it power shaft, is not connected. It's free to spin separate from the compressor. The second turbine is in charge of powering whatever the engine's hooked up to, and the remaining gases are sent out the exhaust.